The architectures for the space industry are about to change. We're creating something that has never happened before. Refueling satellites in orbit is a completely new endeavor. There are now hundreds of companies that are working on different aspects of satellite servicing, and all of them need fuel. And so we went to all of the big aerospace companies, we went to the government customers and said, you should put this on everything. And the answer we got was not just no, but really no, definitely not. And so we ended up with multiple pages of requirements, and they said, these are the things your valve doesn't do, and this is why it sucks. Within 2 months of getting those new requirements, we turned around a new design and said, here's a valve that actually meets every single one of your requirements, and they were shocked because they thought it couldn't be done. They thought they were contradictory requirements. We turned the critics into champions because this was their design. And that's what helped us then to start winning government contracts and to really start building a business. Hi, my name is Daniel Faber. I'm the CEO of OrbitFab. So OrbitFab is the gas stations in space company. We refuel satellites in orbit, in space. At the moment, all the satellites need fuel. You can't move without fuel, you can't dodge debris, you can't stay aligned with the other satellites, you can't stay over the part of the Earth that you might be looking at or communicating with. And so you have to use fuel to keep the satellites where they're meant to be. And when they run out of fuel, you have to get rid of them. Otherwise, they become dangerous debris themselves. So it's the one life-limiting factor. It's the reason why today all satellites are single-use, they're disposable. It's an incredible waste. We throw away 85% of satellites because they run out of fuel. And so OrbitFab's trying to fix that. We are going to make satellites reusable. So I grew up on a farm in Australia, in Tasmania actually, the island off the bottom of Australia. My dad's an engineer, my mum is a scientist. I was probably doomed to do something technical. University of New South Wales in Sydney is where I went for a mechanical engineering degree. And I decided while I was at university that I wanted to do something beneficial for the world, something substantial, something that would be an interesting career. And I decided that getting humans off of Earth fit the bill. It's probably the most significant thing since we crawled out of the ocean. And so I wrote down a list of industries that might pay for the first permanent jobs in space. And you have to understand, in Australia at the time, there was no space agency. There were no companies that could, that had a vision that I could join. And so I realized early on I was likely going to have to become an entrepreneur. So that was a very short list of industries that could create the first permanent jobs in space. I started chipping away at those. I got my engineering degree. I built a dozen satellites around the world in different places, and then started building companies. So OrbitFab is the fourth company. When we sold the third one, which was building small thrusters to move satellites around in orbit, I then was asking the customers from that company, from those customers, what would be the value of making the satellites reusable? We'd seen a huge paradigm shift with SpaceX making rockets reusable, and that seemed to me the logical next step. Eventually, I arrived at the right question, which was, what is the marginal revenue that you could get if you had an extra kilogram of fuel on orbit? And I was absolutely shocked. The answer came back at $1 million per kilogram. It's incredible marginal revenue. And it's true because you're on two exponentials. One is the cost of capital. You have to buy the satellite up front with all the fuel, launch it into space, and all of the cost is up front. And so you carry that cost of capital, that interest rate, all the way up to that last kilogram of fuel. And then secondly, you have to drag the fuel around. If you imagine buying a car with 10 years worth of fuel in a train of trailers behind the car, you burn most of that fuel dragging the car, dragging the fuel around, dragging the trailers around. And so on those two exponentials, even though it's $1 million per kilogram of marginal revenue in orbit, it's not worth putting any more into the fuel tank up front. And so we decided we'd try and crack this nut, and that was the start of OrbitFab. So getting started for something like OrbitFab, it's a challenge. We had to believe a number of impossible things. One was that you could dock satellites together autonomously in space. Refueling doesn't make sense unless you can do that. But thankfully, the technology was almost there. There billions of dollars had been spent on self-driving cars, and of course a lot more now. So we needed self-driving satellites. We saw that as being very close to being reality. But we also had to believe that we could build a gas cap, like a refueling interface for satellites, and that it could work properly in the vacuum environment of space with plasma, radiation, electrostatic discharges, all these types of things. We also had to believe that we as a startup company could actually get that adopted in the market and adopted onto all of the satellites that would need it, because our architecture required that the satellites have an interface we can refuel with, rather than trying to do robotic surgery in orbit to inject fuel into a dead satellite. That seemed far too expensive. And then we also had to believe that we could close the business model where we could invest in that, which would take equity capital, and we could build everything, prove that it works, get it onto orbit, convince people they should integrate this into their architectures, and then we sell the gas cap, we sell the interface, and we have to wait a number of years before they buy fuel. So it's a challenging business model with an upfront capex and a long wait until the market takes off. And so those were some of the challenges we had to face. And when you look at it from a venture perspective, it fits fairly well with that model, in that if this works, there's a huge upside. It's a massive market. $10 billion worth of satellites get thrown away every year in space because they run out of fuel. But to be able to capture that market, you've got to have some capital that's patient enough. And so we were hoping it would fit the venture model. And we were lucky. After about 5 months of not being paid, working out of the garage, refining our plans and talking to prospective customers, we ended up with a pitch deck with about 20 different quotes from customers saying how fundamentally advantageous it would be for them if they could have this capability. And that helped us get a pre-seed investment check from a venture capitalist, a very well-known venture capitalist in Silicon Valley, that helped us get off the ground. We then had to prove our chops before we ran out of money, and it wasn't a lot of money. We had a year or less of funding at that point. And so we also created a relationship with the International Space Station National Lab, and their job on the International Space Station is to do commercialization and science. And they're mostly known for the science. It's a national lab, but they also have to do commercialization, help American companies to find commercial potential in orbit. And so they supported us to fly to the International Space Station, and we put up 2 test beds to transfer water back and forth, to test interfaces, to test the pumps and all those types of things. And NASA told us it was going to probably take 24 months to get through all of the safety processes, because if you put up a gallon of water, you can actually drown an astronaut. They can't brush it away from their face because surface tension is the strongest force in orbit. There's no gravity draining it. And you can't yell for help if you're under an inch of water. So NASA considered this a catastrophic level hazard to put up more than a gallon. And we had 3 gallons of water. And so there are a lot of hoops to jump through. They threw the book at us. We also, when we finished pumping that water back and forth, we wanted to pump it into the International Space Station. And so that also raised a lot of concerns, because if we overpressurized the water pipes on the space station and they leaked, they would have to evacuate the space station. You do not want a space station full of water. And so this was definitely a catastrophic level hazard to them. They told us it'd probably take 24 months. And yet we're a startup with less than a year of cash. So we vowed that we would do it in 4 months, and we'd get to the launch pad in 5.5 months, and we get to orbit within a year of starting the company, but within half a year of actually having the funding and having a napkin sketch of what we wanted to do. And so we jumped through hoops. We convinced the NASA engineers that what we were doing was safe for the space station, which is the primary concern. We had to understand their concerns and get in front of it. We had to move the design and the build so fast that we didn't have answers from NASA, and we had to take our own risks that what we were doing was going to work for the concepts, for the operations, for the safety on the space station. We got ahead in that, we argued our way onto that launch, and we got to orbit within a year of founding the company. And we actually became the first private company to resupply the International Space Station with water. Some of the real takeaways from this experience of getting Orbit Fab off the ground were: understand your customers' requirements, understand what really drives them. For NASA, the engineers there are protecting the International Space Station and the astronauts. That safety is the most important thing. And so as long as we could appreciate that, as long as we could put ourselves in their shoes and understand why they were putting requirements, even then it let us do things that were safe, even if they didn't follow the letter of the requirement. And so being able to push back and to understand and to appreciate where they were coming from was the most important thing that then allowed us to move quickly through what normally is quite an arduous process. And everyone at NASA is well-meaning. And they have a reputation for not moving quickly. As you know, the International Space Station is renowned for being somewhat bureaucratic, but there are reasons for that. Like, safety is very important. But because we were able to work with them so closely, a lot of that fell away, and they ended up being really good partners. So we had now delivered water to the International Space Station, but we also learned that the interfaces that we were looking at and the ones that we'd talked to people that people were thinking of building, they weren't good enough. They weren't up for it. They either couldn't hold together two large spacecraft while they're in orbit, having to do some small maneuvers, and transfer high pressure propellants. They weren't compatible with a low-cost architecture. They would need like complicated robot arms to join them together. So we decided we had to build our own refueling interface. And so we raised a bit more venture capital, and this time we started bringing in strategic investors who could see, again, how fundamentally this would change the industry. And so with those partners and with that capital, we again had a very short runway. We knew that we had to do things quickly. We knew we had to shift the understanding in the market. So we decided that we would build the first satellite refueling system and put it into orbit. And so we built that, the first small fuel depot, a minimum viable product. It was only about this big, and it had on it the first interface for refueling satellites on orbit, a RAFTI interface, the rapidly attachable fluid transfer interface. So we built that interface. We built tanks to hold the fuel that we were putting in there. We found a launch provider who gave us a very reasonable price on the launch. We found a bus provider who gave us a very reasonable price on the bus. We found people that wanted to fly cameras and thrusters, and they either brought them for free or for materials costs. So we put together a mission from all of these parts, and we signed up for a launch that was 6 months away, knowing that we had a 7-month development program. We also knew the launch was likely to slip a little, and so we were taking a risk. But we went for it. We worked on that, and it didn't take us 7 months to build it. It took us 8. However, the launch slipped 2.5 months, and we ended up managing to make that launch. We fueled the satellite before launch at the payload processing facility at the launch site. And so this is the time when it's like the most dangerous. There are people around. You don't want to spray them with these aggressive, possibly toxic propellants. So our interface got put through all of the paces on the things that really drive the requirements on those kind of valves and those kind of interfaces. And then we got it into orbit. It got to orbit, and I have to admit, the satellite has been up there and no one's been wanting to buy such a small amount of that type of fuel. And there were some issues with the radios and things like that on the satellite. But at the end of the day, we had put in space the first satellite refueling valve. And we'd done the first refueling on the ground using it as the fill valve to do that first fueling to get it into space. This is the first time that had ever happened. And so we went to all of the big aerospace companies, we went to the government customers and said, you should put this on everything. You can make everything refuelable now. Why don't you buy a fueling port? And the answer we got was not just no, but really no, definitely not, which was a bit of a shock. But it was actually really great, because when they said no, they gave us reasons. We forced them to sit down and think about what refueling would mean for their operations, how they would go about it, how they would sequence it, when would be the risky times. And so we ended up with multiple pages of requirements, and they said, these are the things your valve doesn't do, and this is why it sucks. And it was wonderful, because we'd already lived most of those issues because we'd gone through the process of getting this to orbit. So we already had an upgraded design almost ready to go. So within 2 months of getting those new requirements, We turned around a new design and said, here's a valve that actually meets every single one of your requirements. And they were shocked because they thought it couldn't be done. They thought they were contradictory requirements. We turned the critics into champions because this was their design. And that's what helped us then to start winning government contracts and to really start building the business. So the lesson in that is you've got to put a product out, even if it's not the perfect product or the end product. Even if you know that it's flawed, don't try and polish it. Building something right is much easier than building the right thing. But it's also much less valuable. You have to figure out what the right thing is, and that can be hard because, especially if you're trying to go from 0 to 1, if you're trying to create a new market, if you're trying to create a completely new product category, nobody's done it before, nobody has the answers, no one has requirements. No one can tell you, make it like A, not like B. You have to just build it and give it to them and invite the critique and criticism, because that's how you get requirements. And in space, that's hard. Moving quickly and doing it at a relative low cost is difficult. And when you do it, you've got to also make sure you engage the stakeholders and really do get that feedback. We were lucky that the people that we were talking to, they saw the benefit of this and they wanted to engage. We got fantastic feedback and they didn't hold back. They threw the critique at it. It was everything we could have hoped for. So some people might consider that flight and that mission a setback. It was absolutely the opposite. It went better than I could have planned, and I expected it to go something like it did. We didn't need 100% performance on orbit. We didn't need to deliver fuel to somebody. We needed to prove the technology. We needed to put it through its paces, and we needed to get feedback from the customer. That mission was 100% successful from the business perspective. We've had other setbacks. We definitely have. And since then, we've grown the company, and we faced problems that every growing company faces. So when it's less than 20 people, it's easy to manage. You can have everybody in every meeting. When you get above 20, you get up to 50, you now need communications processes. You now need managers. And some of the early engineers who are good at moving fast and breaking things now find themselves in engineering management positions, and maybe that's not them. So we went through those kind of growing pains, and we had to figure out how to communicate. We had to figure out how to run things smoothly and effectively. On top of that, we now had government customers who expected high reliability. And so we had to completely shift our engineering culture from move fast and break things to move fast and build reliable products. And that's quite a leap. And so that process took us time to really nail that. Now, we've had great customers. We've had customers that really believe and want what we're doing. And so they've supported us through that. And now our team's on fire. It's amazing. It's one of the things I'm most proud of, beating all the delivery schedules and now on contract to deliver fuel on orbit for the US government next year. It's really an exciting time right now. So today, we've reached a point where all of the technology is working. We've got the gas cap, we've got the nozzle, which is also a gripper system for docking, and we've got all the propellant delivery systems. We have partners that we're working with. Next year, we'll be launching the first fuel delivery vehicle. We'll be launching the first fuel depot with the newest systems, so the next generation fuel depots. Everything now is set with a contract with the US government. We're delivering to multiple US government satellites in 2026. It's a super exciting time right now because everything's coming together. There's hardware in the room behind me that is going through the final sort of flight testing and getting ready to ship out to the launch pad. Where we go next is pretty exciting. The architectures for the space industry are about to change. Firstly, people are thinking about how refueling ports are going to change the current architectures. So first, you can take a fueling port and you can plan on extending the life of the spacecraft past what you had expected. That can add more revenue to your mission. But give that to the engineers and they immediately think, well, now I can shrink the tank and I can put on more transponders or cameras or something. I can make more money out of this, or I can fit it into a smaller budget because I don't have to launch as big a tank, I don't have to launch as much fuel, I don't have to launch like the bigger actuators, I can take the smaller, cheaper ones. Everything starts getting smaller and cheaper. That's just doing what we're doing today, but doing it better. And already that's a massive value. But the most exciting things are the new things you can do with refueling. So there's now quite a number of companies that want to build, we'll call them tow trucks, servicing vehicles in space, to grab debris and remove it. And you can't run a garbage truck if you have to throw the truck away after you tow a couple of pieces of garbage. You need to be able to refuel it. Towing satellites between orbits, distributing them when they come off one launch vehicle. The launch vehicles are getting bigger and cheaper, but they deliver to one location. So if you want to distribute them, you need like an in-space trucking service, connecting flights. Repairs and maintenance and upgrades, these type of things can't be done unless you can go from satellite to satellite with these systems. Those business models are really exciting. And those ones, like you said, that there are now hundreds of companies. Absolutely shocked me. There are hundreds of companies that are working on different aspects of satellite servicing. And all of them need fuel. What we've built here is the fundamental infrastructure you can build that on. And then beyond that, you start to look at manufacturing in orbit, where you need an industrial chemical supply chain. There are commercial space stations going up that are going to need air, water, 3D printer feedstock, minerals to grow plants, like all that industrial chemical supply chain, and of course propellant. That's the really exciting thing. And then in 20 or 30 years, we want to build the refineries in orbit. We want to be that entire material supply chain where we can ingest that material from the moon or asteroids and turn it into the things that we need to sustain life in orbit, to sustain a thriving manufacturing and just a thriving economy in orbit. That's the future that Orbit Fab's building. So at the stage that the company is at now, we're learning constantly. And some of the biggest lessons that we've learned getting here is how important culture is in the company, and just the attitude and the approach. We started with move fast and break things, and that really served us well. But as a startup company, we could take that risk. Now we have customers that are relying on us. Our government customers are relying on us for some quite critical missions. And so we have to deliver. And so we have to look at that from a lot of different perspectives in order to mitigate the potential risks of operating in orbit, but also to make sure we maintain schedules, to do it within financial constraints and all these types of things. And the culture in the company is key. The team right now is really amazing at sort of turning over every rock to find opportunities to beat schedules, keep schedules, get ahead of schedules. Relationships with suppliers matter. Understanding what requirements are and working with the customer is one of the most important things. Making sure the customer and the company are aligned on the risk profile of the mission that's going on, what is acceptable risk, and who's carrying that risk and how that's done. There's systems level challenges that everyone in the company has to be aware of, and the implications of that day to day, just what we work on, and the drive to get things done and get things delivered, that is so key. Because a lot of the launches are not going to move for us. We have to be there when the launch goes up. The customers need the fuel before their satellites run out. And yet it needs to be reliable, and we have to do it very carefully. So many things that we have to balance, and that comes down to culture. You can't build process to do that. Process loses to culture every time. Culture is the most important thing. You have to pay attention to it and think about it intentionally. Thinking about how we've built the culture, I think about the mistakes that I've made. I'm on my 4th startup company, and so everyone has been a learning experience, including Orbit Fab. So I'm now somewhat more attuned to seeing when things are going wrong. Definitely, looking in the rearview mirror, constantly learning from what's happened and saying every day wants to be better. Let's never make that same mistake twice. That's a key then to constantly making new and interesting mistakes, because you'll never stop making mistakes. You're not trying hard enough and pushing hard enough. And so we've got to manage that. And I think the experience of running a startup and the people that I've managed to bring into the team and surround the company with are very good at that. So we have to be attentive to it. We have to learn from things that have gone wrong and do them better. But we also have to engage the whole company in that process as well. We want culture to be a discussion that goes on and is acknowledged and is proactive in the company. So the space industry is at a really interesting point right now. When I started in my career 25 years ago, I can sum up the entrepreneurial business models as give me $1 billion and I will save the world. They weren't particularly sophisticated. They also weren't particularly sophisticated investors. That has now completely changed. There are companies that have, in the space industry, that have started and exited, and those founders and early employees have then gone on to join funds or create funds, and that's created a bit of a snowball effect. Every VC now has space as part of their deep tech portfolio. And I would expect within a few years, every VC will have space as one of their main portfolio categories. That is incredibly exciting. The entrepreneurs that are in the field now are coming with experience and perspectives, but are also able to get advice from people that have been there. That ecosystem now exists. And the investments have been made not just in better mousetraps, not just in better communications and better Earth observation, though there are definitely investments in those, and those are definitely being successful. But there's also new things being funded, refueling in space, for example, but manufacturing in orbit, commercial space stations. Just the number of things would blow your mind. That is just an amazing place that the industry's got to. And these investments are going to start paying off over the next few years. We're going to see some of these things come about, and the infrastructure for a thriving in-space economy is being built. What we build on top of that is going to be even more exciting. People will find applications that have customers on the ground, to start with anyway, but finding those customers using all of the tools that are now being developed, that's what really excites me. So for other founders, I mean, first of all, this is an amazing time to be in the space industry. The VCs get it. The VCs now are ready to fund this. The US government, who's the biggest customer still for space assets and services, they are also looking for faster innovation. The larger companies are recognizing that they can find innovation in these smaller companies. The whole ecosystem, everything is moving in the right direction. Take advantage of that. Put the network out. Talk to a lot of people. Realize that a lot of the industry now wants to see this happen. And really, fundamentally, the industry has been dominated in the past by engineers, right? Engineers and scientists have run the space industry. There is no shortage of fantastic engineers in this industry. There's still a shortage of entrepreneurs and business people. All the things that go along with that, we need to bring in from other industries. But if you can do that, if you can put that together well, then there's huge opportunities. The best piece of advice, well, so I'm not sure what the best piece of advice is that I've got on this journey. I've got a lot of advice. There's a lot of things that I haven't done that the company's now trying to do. And frankly, we're creating something that has never happened before. Refueling satellites in orbit is a completely new endeavor. And so nobody has done this. And for many things, we can't get direct advice. But we can get a lot of advice on related things. And so my background wasn't working with the US government, but the US Space Force is our biggest customer. So surrounding myself with an advisory board that have that experience has been absolutely critical. Similarly, as we grow the company, we go through investment rounds. We have to use that capital very carefully, and we have to monitor that with internal processes and things. Having advice on how to structure that has been really key. But there's almost no aspect of the business that doesn't benefit from a great advisor. So as a founder, I don't think I could live without my executive team. The people that bring experience in areas that I'm just not an expert in, or that just I'm not interested enough in to become an expert. And so finding those people with complementary skills and experience and interests is absolutely key. The most unexpected thing on this journey, I think, is how lucky we got. We set the company up in 2018, And within a couple of years, the Space Force was founded. There was a clear recognition that the US government assets needed fuel. And so there's an adage I'd heard in Silicon Valley, and I think that we've lived into that 200%. It is better to be lucky than to be smart. So Orbit Fab is based here in Colorado. It's a great place. We're a mile closer to space already. It's also got the highest density of US defense facilities and things in the country. The space operations in the US happens here, which is pretty exciting. There are now hundreds of companies in the Denver area and the Front Range area, aerospace companies. It's one of the most exciting places to be. So you can find Orbit Fab by coming to Colorado. You can find us online, orbitfab.com, on LinkedIn, on most of the social medias. But also, we're looking to continually grow the company. We're looking to help other entrepreneurs grow the space industry. We'd love to engage with people. So if you want to get into the space industry, or if you're in the space industry and want to work on, frankly, what is one of the fundamentally most important pieces of infrastructure that are being built, we'd love to hear from you. We'd love to have you on this journey as well.